See, can you see my PowerPoint slide? Has it started?
Yep, that's good.
Yeah, okay. So I'm going to talk to you about a place in southwest Greenland called Ikkefjord and some remarkable tufa deposits that grow in spectacular columnar form along the bottom of this shallow field. And myself, I left university in 1998, but when I was at last stage of my university, Imperial College, I led a diving expedition to Ikkefjord to have a look at these structures. And this expedition led to my PhD, which was studying these formations in the fjord. And I sort of parked that back in 1998 when I started working. For the past 22 years, I've been working as a marine geophysicist and working around the world on various projects, oil companies and wind companies and cable companies, etc. And then 4 years ago, Ikkefjord came back into my life, and I'll come on to that. So Ikkite is it's a calcium carbonate hexahydrate chemically, and it's actually a high pressure, low temperature hydrated phase of calcium carbonate, which means that really it shouldn't be found on Earth, certainly on the surface of the Earth, because those sort of conditions don't normally occur. It was synthesized in the laboratory in 1831. You can form it in the laboratory if you can suppress the formation of calcium carbonate to the point of saturation of ikkite, but it wasn't found naturally until 1963. I mean, there have been a number of natural discoveries of ikkite. Typically, it's been found as amber-colored crystals in the deep sea sediment cores, as could be seen in the slide here. In alkaline lakes such as Mono Lake in the Sierra Nevada in the States, on some shorelines in the Arctic, and in some springs in Japan. And it's quite likely a very common mineral. It's probably overlooked though, or missed, because it will quite quickly decompose back into calcite and water if it's not preserved and kept cold on discovery. So the other location where natural ikkite was found is its type locality, which is Ikkefjord in Greenland, where it occurs as these columns growing out to the bottom of the fjord. And these have been known for centuries at least, and they're incorporated into Inuit legends. The Inuit have a saga that says that these are the frozen remains of Norse settlers that were driven onto winter ice and fell through to drown. Because in Ikkefjord, we've actually got archaeological remains of Viking and Norse, as well as Inuit settlers. So there has been human habitation there for some time. So the location of Ikkefjord, it's in the southwest corner of Greenland. And you can see, if my mouse will show, we're talking about the inner part of the fjord, which is actually a hanging valley on the main fjord, which is much deeper. And the outer part of Ikkefjord is maybe 200 to 300 meters deep, but we're talking about this hanging valley that's no more than about 28 meters deep, which is how the columns have been seen. The adjacent fjord, Arsuk Fjord, is quite important for two reasons. There's a mine at Iviktut, which I'm going to talk about next, and also a Navy base, a place called Gronadel, just about where my cursor is there. So how was it discovered? Well, the mine in Iviktut in Arsuk Fjord was one of the only sources of an ore called cryolite, which was mined and exported by the Cryolite Corporation, a Danish company, I think starting about 150 years ago. And it's an important ore because it lowers the melting temperature of bauxite when you're trying to produce aluminium. And it's synthesized now, but up until at least the Second World War, the only sources were from natural mines like Iviktut. So it's strategically important during the war, and it was protected by American and Danish Marines. And the Marines stationed at Gronadel, adjacent to the mine, used to go to Ikkefjord for fishing and recreation. And so they became aware of these columns. You can see them at low tide on still conditions from a boat quite plainly. And working at the mine in the late 50s and 60s was a Danish mineralogist called Hans Pauli. And he was taken to Ikkefjord on a picnic with the Navy. And the Navy took some divers to collect some samples of the column for Pauli to have a look at. And Pauli identified that what they were dealing with is a new hydrated carbonate that he called ikkite after the fjord, and that's the type locality. Ikke, by the way, is the Greenlandic word for shallow. So it's the shallow fjord in Greenlandic. And in his publication, Pauli reported that the divers collecting the samples had witnessed a forest of giant columns formed from the mineral in Ikke Fjord. This publication was in English, but it wasn't very widely sort of appreciated publication at the time, and it sort of disappeared into the annals of history. I'm just going to talk briefly about the general geology of southern Greenland and where Ikke Fjord fits into sort of the geology. And you've got some very old Archean gneisses into which you've got these. There's a large granite body called the Julienahab batholith, which was formed in the roots of a sort of an Andean type subduction volcanic chain. And then there's a period known as the Garda province, which was a rifting, continental rifting, as the supercontinent Columbia started to rift and these sort of pre-existing rocks started to fracture and pull apart. There was the intrusion of a number of alkaline bodies, and there was some sedimentary units laid down as well that are all classed as the Garda province. And these ancient rift zone sediments and volcanics have been quite extensively studied because they are only partly metamorphosed and deformed and are very well exposed. And adding to that, the glacial erosion in southern Greenland has carved out fjords through these sediments and volcanics, which gives you sort of unprecedented three-dimensional access to the roots of these volcanoes and intrusives. And they're also quite rich in minerals, and they contain economic reserves of rare earth elements and uranium. And if you're interested, I've noticed on the EGS lectures webpage that there's actually another presentation there about some of these giant dikes, Garda dikes in southern Greenland. So you could have a look at those if you're interested in following up. So going back to Hans Pauli, the mineralogist working at Ivigtut, and at the same time he was discovering the composition of these columns in Ikke Fjord, there were some British geologists working on mapping the Garda intrusives, alkaline intrusives, including what's called the Gronnedal-Ikke complex that Ikke Fjord dissects the southeast corner of. And these two of these British geologists are actually both recipients of the Society's Clough Medal. There's Dr. Henry Emelaus, the late Dr. Henry Emelaus from the University of Durham, and Professor Brian Upton at the University of Edinburgh, and their work have been very important to us, studying the Ikkeite deposits in Ikke Fjord. So the Gronnedal-Ikke complex is an 8 by 3 kilometre, formerly ovoid intrusion, which is the roots of an alkaline volcano. It comprises concentric rings of steeply dipping syenites with a centrally in place plug of xenolithic syenites and carbonatites. And then the whole complex was partially fault deformed with Garda tectonics movements leading to its present outline. In 1994, Pauli's account of the Ikkeite deposits was rediscovered by myself, who was actually inspired by a professor at University Imperial College, and also by a group of biologists and geologists at the University of Copenhagen. And we both formed expeditions to go to Ikke Fjord to have a look at these Ikkeite deposits. And these two teams seeded what became known as the Ikke Project. And so the Ikke Project, they comprised of geologists, geochemists, biologists, zoologists, botanists, aided by divers. And we've made 13 expeditions to the fjord between 1995 and 2007 to study these columns and the surrounding fjord environment. Here's some sort of fieldwork pictures from that era. And what did we find? Well, exactly as Pauli had described, a forest of spectacular tufa columns made from Ikkeite, amongst other calcium carbonate minerals. And these were up to, well, at that time, the biggest ones that we measured were 18 meters high, and we mapped around 600 of them, scattered around the fjord. But I'll show you maps later on to show you some of how they're sort of concentrated. And not only are they beautiful sort of structure. They're also festooned with a lot of marine life, and which has been well studied by the biologists and zoologists. And the part of the life within the columns are some extremophiles, because there's a slightly hostile chemistry to the formation of these columns, and it takes a sort of an extremophile type of organism to live in that environment. And these sort of organisms are studied because they can do useful tricks, chemical tricks that could be patented for commercial applications, enzymes and the like. And we discovered that these columns grow very fast. We cut a few columns, and within a year, 0.5 meter or so new growth had formed. If you leave it longer, they just carried on growing and growing. So it's a very rapid precipitation of ichthyote in Ica Fjord. And mapping the deposits as we did back in the mid-90s, we discovered that, as was poorly actually identified or suggested was the case, the columns are constrained to the outcrop of the Groenendael-Ica complex, and all these red dots are the ones that were mapped from the side-scan sonar survey done in 1996. And outside of that area, they're unknown, basically. The expeditions also included the sampling of all the different water bodies in the area, from the sort of spring waters, sea waters, lake waters, rain waters, and also samples of the ichthyote carbonate itself, and the other rock components of the Groenendael-Ica complex. And what was determined was that the columns are forming because of a reaction between a carbonate-loaded spring water reacting with calcium in seawater. And what was revealed by the isotopic analysis is that the waters coming out at the bottom of the fjord are meteoric waters, percolating down through the Groenendael-Ica intrusion, dissolving carbonate from the carbonatite, and that water emerges at the bottom of the fjord. Being fresh, it rises up through the seawater, and as it rises, ichthyote is precipitated with a reaction between the carbonate in the spring water and the calcium in the seawater. And what favors the deposition of ichthyote is, well, what we believed at the time was the high phosphate content of the spring water. Phosphate is an inhibitor to calcite formation, to the point that you can favor ichthyote precipitation. And so we produced a number of publications, and including this one on the right, which we call it's a Danish publication, in Danish. The Danish for book is bog. So this is our Ica bog. So we were the first ones to have Ica bog. So I have to have words with J.K. Rowling about that. She's possibly stolen our thunder. But anyway, we thought we'd understood the whole process of what was going on in Ica Fjord geochemically, and we sort of parked it there. But then in 2008 and 2010, publications were published that announced that ichthyote had been found forming in Arctic and Antarctic sea ice. And this posed the question that if it's forming in open seawater away from the chemical influences and constraints of the system, such as the Groenendael-Ica complex in Ica Fjord, then can it be made to be formed somewhere else in seawater and therefore be used to sequester carbon from the atmosphere? And this notion was boosted further by some further laboratory studies done to emulate the formation of ichthyote naturally in seawater. And it was found that phosphate was not actually needed. I mean, you do need an inhibitor, and magnesium common in seawater can actually also promote the reaction, as long as you have a high pH, which is the other sort of critical condition to achieve. So ichthyote has become a mineral of interest as a sequestration medium for carbon, and particularly as it's precipitated very rapidly in seawater under the right conditions. And we've rekindled the Ica project starting in 2017. One of my ex-colleagues from University of Copenhagen during my PhD time is Dr. Gabriel Stockman, University of Iceland at the moment, who's been working at CarbFix, which is the industrialized removal of atmospheric carbon dioxide. by pumping it underground where it reacts with groundwater to form calcite in Iceland. So she's a geochemist and an expert in this sort of field of carbon sequestration. And we've also been joined by scientists from Stockholm University, University of Gothenburg, and Copenhagen, and myself. And a further motivation for rekindling the ICA project is concerns over the future fate of the columns in ICA fjord, because they're showing signs of stress, and we wonder if it's related to the fact that the water's swirling and entering the fjord systems in southern Greenland are becoming warmer, with changes in ocean currents believed to be related to global warming. So we've made 3 expeditions in the past 4 years back to ICA fjord. The first in 2018 was more of a sort of a test of logistics and to get some extra samples, just a sort of an interim test on how things are going, and also to do a drone survey, which was required to apply for a permit to use a multi-beam sonar in the fjord. The fjord's protected under Greenlandic law, and you can't take a vessel with a draft bigger than ½ a meter there. And so we used a drone to make sure that we could prove to the authorities we knew where the shallowest columns were, so we could avoid them during the survey. And then in 2019, we did the multi-beam survey. We rented a Norbit high-resolution multi-beam sonar and made the first accurate, detailed maps of the columns and deposits. The point cloud is probably the most revealing of the multi-beam data sets, and well, this is actually a DTM set in amongst a point cloud model made from the drone survey, and you can see there's quite a line of columns along the sort of southeast side of the fjord here, but the columns do occur everywhere else within the outcrop of the Groenendael ICA complex, but they are concentrated in the inner fjord in what we call the ICA column garden. And derivatives from the multi-beam survey have been made into a series of PDF charts and etc. This is a fly through that I've made of the point cloud data, just to give you an impression of how these structures would look if you could drain the water away. I would say the typical height of these columns is sort of 5 to 10 meters. The tallest ones can be up to 20 meters high. And this is through the ICA column garden. We've mapped up to 1,000 of these now, the smallest being maybe only ½ a meter, but the tallest, like I say, 20 meters. And in 2019, we were also graciously helped by the Royal Danish Navy. They have warships patrolling in Greenland, and they're also looking to support scientific expeditions, which was helpful for us because it's quite an undertaking to get diving equipment up to operate in Greenland. So here's some pictures from the diver support. And then last summer, we revisited ICA fjord. We wanted to go in 2020 to do what we did this summer, but we weren't able to go because of COVID restrictions. Greenland's been very shut down with COVID. They've got very limited medical services there. So they just decided to close their borders, which was fair enough. So we went, and this summer we did a lot of water profiling, 78 CTD casts in ICA fjord and leading out into the open water to record the sort of the vertical structure of the water bodies in there. And we also did a sub-bottom profiler survey. I think it's about 43 lines of sub-bottom data being acquired and being processed. And we were joined by a German natural history production company. They're making a program about the fjord, which will be aired next year on German television, but I'm hoping it might get sold on and be more widely viewed. And just going back to the products that we've been making from our recent mapping, we've got these PDF charts, which we've also been producing for the Greenlandic government, because they're interested in protecting the site and they need some better charts of the water depths and the limits of the deposits and their current distribution and status. And so we continue. We're at the stage now where we're looking to attract more funding and to expand participation in our project to include other researchers. We've got a couple of new PhDs starting in Germany and in Sweden, Gothenburg, looking at carbon sequestration with ICIAI, and also rare earths in the carbonatites. I mean, there's a lot of rare earths in the carbonatites in the granodiorite complex, and they're of economic interest at the moment. So we're concerned that might actually be a threat to this site. And we're also hoping we might be able to involve some archaeologists, because there's some archaeological remains in the fjord and have yet to be fully studied. But that's it for what I wanted to give you this evening on Ikkefjord and Nikiai.